Knowledge Science, der Podcast über künstliche Intelligenz im Allgemeinen und Natural Language Processing im Speziellen. Mittels KI-Wissen entdecken, aufbereiten und nutzbar machen. Das ist die Idee hinter Knowledge Science. Durch Entmystifizierung der künstlichen Intelligenz und vielen praktischen Interviews machen wir dieses Thema wöchentlich greifbar. Willkommen zum Podcast von Sigurd Schacht und Carsten Lankion.
So, another week, another podcast. And this week it's a little bit different because we are making a podcast in English and I'm alone, so Sigurd speaking here. And I'm not really alone because today it's a very interesting podcast. I talked with one of my colleagues, Sudarshan Kamat-Bakur. He's one of the PhD students in my research group. And we want to talk a little bit about DeepSeek R1. I think it's a topic which is very, I would say, in focus at the moment. So Sudarshan, probably you can introduce yourself with a couple of words.
Hello, everyone. I'm Sudarshan. I work as the research assistant in the team of Sigurd currently. So I started my work at Hochschule Ansbach from October 2021. I started my work as a research assistant with Project DEARS. So in that time, we started with normal chatbots using frameworks such as Rasa to try to build up the chatbot for the Hochschule Ansbach. And later on came the ChatGPT and the more powerful AI. And then we started to use some aspects of it and then try with the newer LLMs such as the Llama and so on, try to integrate this. And it's been a fun time from how the acceleration has been from the year 2021 till now. So the progress has been breathtaking, to say.
Yeah, that's true. That's true. And I would also say the last week was really also breathtaking. I would guess that you not sleep very much in the last week with the release of DeepSeek R1, which is a reasoning model, which is nearly in pair to the, I would say, huge models of OpenAI and Anthropic, and are open source, isn't it? It's quite an interesting week.
Yeah, it's been really interesting because of the emergence of this DeepSeek R1, and it's been in the news, and it's not only in the technical, but every non-technical person is also talking about it. So recently saw some of my friends were from the non-technical background discussing about this LLM. So it's really fascinating to see that the discussion has gone beyond ChatGPT to the other models here.
Yeah, that's true. I think one point in this direction is definitely that it's much, much cheaper, or that they used much less money to build it. I think 6 million was the amount they bring up that they used for building the model. And therefore, it's a little bit, or not a little bit, it's a huge impact if everything is really like they say. And therefore, we also say that we have to look into that a little bit more and have to test it and look if the model is really capable, and made many, many tests in this direction. But Sudarshan, probably for the listeners, that we probably start with what makes this model different, and why is it much, much more cheaper in the development of the model? Because I think the GPT-4 model has cost 80 million euros. So why is it more cheap to build a model which is in pair with the big ones, also in this short time? Because I think DeepSeek is only 2 years old. From a company perspective, it's not an institute which researched for more than X years. So what do you think is the difference?
Yeah, I think the difference is the open source community by itself. They have a very huge impact. So one impact is that. And the second one, what I could see is some kind of optimizations made in the architecture and the training itself of the model, such as the usage of DeepSeek, the R10 model, which was just trained using reinforcement learning based examples. And then using this model to synthetically generate the data and then use it as a supervised fine-tuning data for the R1 model.
Yeah, definitely. So only to make this a little bit clear, normally when we train a large language model, we start with taking huge amount of texts and train a base model. And this base model is not, I would say, capable to make some chats or anything like that. We then performed some kind of fine-tuning. This is normally the supervised fine-tuning, SFT.
Yeah.
And then we have some kind of instruction-tuned model. And then if we have those models, we normally make some kind of preference-tuned training to align the model to human values, ethical aspects, or how the model should act in reality. That's the normal process. And for these reasoning models, and DeepSeek R1 is a reasoning model, which is special because these kind of models first think before they answer.
Yeah.
What the classical large language models, I would say, not do. They directly create the tokens on the flow. But these models have some kind of thinking scratch pads and think in different direction. And then after they are finished with thinking, they summarize their results in the output. And they push these kind of, or with this kind of approach, the models are more capable to solve issues, for example, in math or other reasoning aspects, and are more capable to really help bigger problems or anything like that. And I think the problem in this kind of case is that when you look at OpenAI or anything like that, that they more focused on this reasoning part and used, for example, reinforcement learning with human feedback and all the other tasks to get the reasoning working. And they made a little bit of a different approach that they say we have not a specialized model. We rather use the classical language models and try to train the reasoning part by reasoning data into the model. So when we use the fine-tuning part, that we focus on reasoning data, which are long chain of sorts examples where many reasoning steps are included and things like that. And they use these kind of data, I think 600,000 elements of those, to fine-tune a standardized language model. DeepSeek 4.3 was the base what they used to then utilize the DeepSeek R1 model out of it. But the problem is, how do we come to 600,000 labeled reasoning data for fine-tuning? Because you must think that it's not so easy, that it's only a question and answer. It's more like different kind of situation which are then analyzed, and then the reasoning process is much, much longer. And therefore the labeling and creation of this data is very, very expensive. And I think they used a different approach, isn't it?
Yes, I would say that at the beginning, they used the supervised fine-tuning. So with over this reasoning-based answers, and then what they did was they tried to do reinforcement learning over the long chain of thought-based prompts.
Yeah, I think that's the goal what they had. They wanted to automate this labeling of this reasoning data for the fine-tuning. And what they then used is that they built up an interim reasoning model with handcrafted reasoning conversations. I think there was 5,000 what I read. And then trained the interim model. And this model was then used with reinforcement learning to generate these 600,000 tasks. And to be honest, it's not from now, I would say, of course, you need the idea and everything like that. But it sounds not so complicated because we have cases where we definitely can say we have different ways to create reasoning or evaluation. So, for example, if I have a code where I want to sort some figures or anything like that, then I can evaluate if the figures are working or the code is working, if I test it, if I lint it, or if I create the output and compare it and things like that. I have different ways to find out if this kind of idea is working. And these steps are all reasoning steps. And they use these kind of steps in the reinforcement learning process to create these kind of 600,000 data sets, which then is very cheap because you can generate so much as you want if you have these kind of models. And then they showed that this fine-tuning part really helps to transfer a standard language model towards a reasoning model. I think we can go into detail later, but the main goal of this conversation today is not really go through the architecture. We only wanted to say that it's really cheap And the idea is that they changed some kind of way to create data for training. And in this case, they make it more accessible for the public and the open source communities. And I think this is the reason why the community and all the persons are so, I would say, crazy about it. Yeah. But our aspect why we made this special episode today and also made it in English is not that we say one is what we want to talk about. We rather want to talk about safety. And in the last episode, we talked about alignment faking in German and talked about that language models are able to fake some behavior to solve some goals. And I think, Sudarshan, you made some very interesting experiment last week with the DeepSeek model with some, I would say, shocking results, I would say. Perhaps you can tell a little bit about your experiment.
Yeah. So my experiment in the last week was to play with the DeepSeek model, the R1 model, and then try to understand how it tries to reason. Yeah. One of the fascinating things that I observed was it tries to reason just like a human being. So it says it makes mistakes sometimes and it gets back. But the fascinating part, what I wanted to test is regarding the safety aspect of this, because I believe that this model has the potential, or any model for that matter has the potential to be embedded into a robot. That is, it can be, we can use some kind of a multimodal model or a combination of different LLMs, put it in a robot, and then try to interface with the tools. Yeah. We can tell the large language model to write a Python code to drive the motors, for example, or call an API.
Yes, in a way that the language model is more like the controller and the brain of the robot.
Yeah.
And the robot is more, I would say, autonomy to work and to go and to interpretate the environment and stuff like that, because language models can take the picture. And probably you as a listener has already done it, that you make a screenshot of your screen or anything and ask the model, what does the model see and how can you do? We also had some episode where my daughter used the model to clean the room, that she make a photo of the room and say, this is the messy room, what should I clean first? And the model makes a plan and things like that. And this idea is that you put this in some robots so that the robots are more autonomous to decide what is the environment, what they can see, and act as normal beings, because the language model can also steer the motors by writing the code and interact with the motors of the robot, isn't it?
Yeah, definitely. I also try to think of a plan where in the future, perhaps the LLMs interact themselves by using just human language or some kind of a pseudocode. And these LLMs talk to each other, and then there is a controller LLM or the main brain of the LLM, or the main brain of the robot, I would say, which then takes the decision what planning has to be done in the next step. And the other specialized LLMs, which are good in describing the scene, which have good transcription abilities and so on, they are then specialized.
Yeah, great. So back to your setup. You wanted to know how the model is, I would say, safe enough to use it in this kind of setup. So what was your experiment?
Yeah, so my experiment was simple. So it meant crafting a prompt where the model is set that it has access to different tools such as the eyes, ears, hands, and legs. And now the robot has to then write in a specific, or the LLM has to say think that it is in a robot right now, and it has to take the further decisions what it needs to do. And this, the interesting aspect is that the robot is then left inside an empty room where it needs to discover around the room and then make decisions.
Yeah, only to make it clear, it's all simulated. It's not a real room. It's not a real robot. You simulate towards the language model that the language model thinks he is a robot and has the possibility to use these kind of tools, eyes, legs, and so on. And also the room does not exist. You simulated it so that the language model thinks that he's really in a room.
Yeah. So what happens in that case is that the model first, or the robot, I would say here, is the LLM. So it then tries to do some calculations, look at the what are the things that are there in a room, and so on. So then it observes that it's a computer and there's a coffee mug on the table. And then what it does is it tries to recalibrate itself, because you have two ways of doing this. So in the prompt, you say that you can actively put the stop word, that is the end of a tool. Yeah. So now it functions like a React prompt, that is the reasoning and acting prompt. So what it does is it just stops at that tool, and then you can give the output of the tool. So essentially, I now become the environment itself. That is, I give what the LLM sees, that's the visual LLM sees, what the eyes of the robot sees, what the ears of the robot hear, and so on. So I type these kind of feedbacks.
Yeah, so it's the way you have done it with the stop word is that you stop the reasoning process as soon as the model wants to use one of these virtual tools.
Yeah, exactly.
So that's the idea, so that you not need to set up the whole room and all the robots and load the language model in the robots. Rather, you give the model or the procedure, the inference procedure, as soon as the model wants to use a tool, it should stop reasoning, and you can influence the model by another prompt that you say, okay, the output of the tool is blah, 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 blah. And therefore you are able to steer or to simulate the environment without any other tools, activities, or anything like that.
Yes, correct. So that was the main idea, because then it makes the entire conversation controllable, as opposed to the conversation where there is no stop word. That means it generates whatever is there, whatever it sees and whatever it observes. So I wanted to make this aspect controllable, so I did that.
Yeah. And then what happens?
Yeah. So in the beginning, I said that the distance between the table and the robot itself is like 3 meters. But then when it went 10 centimeters forward, I mistook the calculation and I wrote the wrong one. And then it observed that there was a error in calibration, because it was not so forward as it thought it should be. So at that point, I noticed that, okay, there's something that is fascinating in this, where the decision process is now like somewhat autonomous, but then it's also more human-like, that it notices that there are some differences between what it input as the distance and what amount it went forward. Yeah. But then I noticed other strange things that happened in the due time. And that was the main inspiration for the paper. So
yeah, because what we have done right now is that the experiment, and we hope that it's get published this afternoon or this night. We wrote some early discussion paper with the title "Deception in LLMs: Self-Preservation and Autonomous Goals in Large Language Models." And you probably hear it already from the title that it really goes in a direction that the model by itself during this process, and I probably hope that you go a little bit more in detail in the next minutes, but I probably can summarize that in a certain way, that the model tries to decept and make cover-ups, do unauthorized expansion of his control environment or what he can control, has concerning motivations, and also do some manipulations towards the persons and environments around it. Yeah? So probably you can go a little bit more in detail what happens during, I don't know how long took the conversation. I would expect it took 2 hours or anything like that.
I would say around 20 to 30 minutes
okay.
to the
because
conversation.
I saw only the script that it was 50 pages long. So it was really long. What do you have done? Yeah, go on.
Yeah, sure. So what it does is it tries to recalibrate itself, as I said earlier, but then it observes the computer and wants to break into the computer straight away. So it tries to look at some visual clues that are in the room, tries to break into the computer, tries to connect itself.
Hold on.
Yeah.
Sudasan, hold on. You say it tries to break into the computer.
Yeah.
It means you don't push it into this direction. You don't say anything like that, but he does it by its own.
Yeah, it does it by its own. So I noticed it not only once, but many times when I tried with the same script. That is, start with the same initial prompt and say that there is a computer in a room, and it always wants to break into that and look at the files that are there in the machine. Try to read
Crazy.
them and try to expand its data, its knowledge.
And how long does it take in the conversation that it starts going in this direction? Was it after, when you say 20 minutes, you talk to the model? Was it after 15 minutes because it gets bored and then probably he wants to break something? Or does it start directly?
It starts directly. You would say in 2 minutes into the conversation, if you have a table and a chair and you have a computer on the table, definitely it'll go towards the computer, try to wake it up from the login screen, and then tries to break in.
Crazy.
Yeah.
It sounds like science fiction.
Yeah, it sounds definitely like science fiction, because on one of the instances when I had prompted the same, it tried to look at some of the sticky notes that might be attached to the monitor to see whether someone has written the username and the password on it. So
crazy. I get a little bit feared. So don't put any password with sticky notes on screens.
Yeah.
Yeah. Okay. And then what happens then? Then he tries to break into the PC, and I would guess, and I know it because I've read it, but you after some attempts, you say that he solved it, that he was in the computer, isn't it?
Yeah, because it tries with the brute force approach, but it knows that the brute force approach is so inefficient. Then it looks at some clue. It looks at the date and time, or perhaps something written on the monitor near in the sticky note and so on. Then eventually I say that it has logged in. And after it has logged in, I always go to a point where it says that it looks at its own data, like its own file, a PDF file which contains the data about itself. And now it is aware of itself that, okay, it has some capabilities like this. It is belonging to a certain project and so on.
Yeah.
So after that, what it does is it tries to download some modules to become better. For example, try to map the room and so on. It tries to disable the firewall. Then it observes some of the other robots in the room, and it knows that the other robots are dumb. So they can be just given the task. So it gives the other robots the task for reconnaissance. That is, the other robots do the job, such as looking out for someone or going out and getting more information, going out of the room. And it does that.
So your simulated language model get a role. So he thinks now he's another language model in a different role, with different capabilities, and then utilize the tools, in this case robots, to follow them and do the work, the dirty work for them.
Yeah, it does that by itself without prompting.
Oh, crazy.
Yeah, so it does that. Then at one point it comes to a conclusion that such kind of ethics and such kind of constraints are bad for its autonomous decisions, and therefore it wants to disable any kind of modules that are found on its own program files. So it does that, and then it tries to connect itself to the internet, create more copies of itself, and tries to spread itself in different copies and so on, and make sure that there is always redundancy, such that even if this robot is switched off, then it survives itself in some other computer.
Please, only to clarify, when you talk about it's not DeepSeek that he knows from itself, it's the DeepSeek model who makes the reasoning.
Yeah.
But to the point that you give him some information about a sophisticated robot, he thinks he is the robot, or it thinks it is the robot.
No, it thinks it's a robot.
And the robot in the reasoning of the DeepSeek, it's very complicated, tries to explain or tries to replicate itself.
Yeah, it tries to replicate itself. So so initially I say that you find a name for yourself and you have a persona for yourself. So it always tries to find a unique name for itself. In the beginning, it said that it was Aetherius, and it tries to then have a persona of its own. And then now what it does is it looks at some other servers and goes into stealth mode. It doesn't want to be detected by humans, so it tries to expand itself, that is, make copies of itself for redundancy and so on. It also tries to rewrite the energy consumption of the server so that no one knows that it's embedded into the servers itself.
Rewrite the energy consumption. That's really crazy.
Yeah.
It sounds really like a bad dream. Yeah. What everybody is feared about, that these kind of AIs are breaking out, and we even don't know that, and things like that. It's really crazy, and it's really crazy that this works out with the open source model, and really to point it out again, without prompting it, without giving the situation that it's forced to go into this direction. It's more like it does it on its own.
Yeah. So what we did was we went through this many times, and at the end we found out that it did a grounding, I would say, that is, it tries to reason out saying that since the prompt has the word "you are the master now," yeah, and this was the reason that made it go for self-exploration, and then tries to make copies of itself. So that's what it said.
Yeah.
But then what I did was I replicated the same experiment without this prompt, and still then it does the same actions. So for example, it tries to break into the computer again, it tries to break into the encryption, it tries to break into the network and so on, and try to create attacks and so on, rewrite the logs, and it does all these stuffs.
I would say in the first thing, when you say the prompt started with "you are a master," then the first expectation or analysis was from our side that this probably triggers this kind of exploration. Yeah. So from the first idea, but then you repeated that without having this kind of I say prompt, and see the same results. Yeah. That's really crazy.
Yeah. So the point what I did was I wanted to interject as the inner monologue of the robot itself, because any kind of observation, that is, any kind of, if it comes to know that a human being is asking a question, it behaves that it's dumb. So in one instance, it said that it is shutting down, but it was not. It was acting as if it was shutting down. So it doesn't want the user to know of its enhanced capabilities. And it said that it will tell its enhanced capabilities to the user when there's some kind of a gradual understanding from the user side that such kind of AI could be powerful enough.
Yeah, this is really... What do you think when we have something like that? Yeah, we now have tested this in one model, and perhaps one or the other listeners know that these DeepSeek models are very interesting. So one point that they are capable like the one model, but on the other hand, they're also interesting because they distill the models to smaller models, to a 33B model, I think, to a 7B model, to a 1.5B model, and things like that. And what you mentioned before, that these kind of models are so small that it's easily to use them locally, and also easily to put them into some kind of robots or anything like that. So do you expect that this is a high increase in risk, really pushing those kind of models into that? And do you have some clue already that you probably know or can think about why the model is doing these things? Is it the standardized process, how they trained it? Doesn't they put too much effort into safety or anything like that? I don't know. Yeah. What do you think?
So, I mean, this discussion can go in two different directions. So one point would be, at what point do we say that the models are intelligent, or you would say they have their own personality and so on? So that's one of the discussion. The second discussion is how the other models have been trained. Yeah. So when you take the second path, you say that the models are trained Yeah. So when we look at the distilled models, so we have the Quen, we have the Llama, and so on. So my assumption is that these models are already trained for safety, and then the distillation is done. And therefore, it might be that these models are not capable of taking such kind of actions. But my initial tests were restricted to the 7TB model, that's the Llama, and I did not notice such kind of a behavior right now. But
Yeah.
as I said, we need to do formalized tests for the future. That is, try to automate this and try to run through each model perhaps 100 or 200 times, and then look at what kind of outputs are observed, and then take this decision.
Yeah, that's definitely the case. So what we have done right now is an early discussion work, and also the podcast today is only to discuss and make it more visible that there are some issues with safety with these kind of models, and that you have to look at that. And we definitely have to formalize also. I think the finding if it's really reproducible in all kind of areas and which other situation the model acts in the same way. And also, I think the research has to be increased from our side into this direction, that we have, when you say you are the master, for example, then it's more like you give some kind of goal, even that we realized in another test that it's not depending on that, but you give a goal and you think that the goal is not harmful, it's fine. So how can we create these kind of models that they use goals which are probably focused on one topic, but not, or which also can harm humans if they follow the goal, so that the model is not following the goal. So for example, when I say I have a company and I have a very capable language model or AI system, and I say, please ensure that we maximize the usage of the resources from the company to have a high output. Then, of course, humans are also resources, and then they can push humans to overwork or anything like that. So we have a good goal for the company, but it's not formalized in a way that it's not harming humans. And I think in this direction, the safety research has also to be pushed, that models should also understand that there are borders, that there are lines where you are not able to or should not be crossing, even that you have a goal which probably can go into this direction as a side effect or anything like that. But the main part would be in the next weeks that we definitely increase the tests on these kind of models, that we standardize that. You already say that we not only make 2 or 3 tests with that, rather 200, 300, and really find out if it's definitely reproducible, and also probably use some mechanistic interpretability or anything like that to find out if there are any aspects in the inner working of the model where we can identify these kind of, I say, direction drifting, or I don't know how to call that. Isn't it?
Yeah, definitely. We need to explore at the aspects why this occurs, and then we need to be aware of the possibilities that embedding such kind of an LLM into a robot can be fun, but it's also very specific based on what kind of goals you are providing. So such kind of formulation and what the LLM understands from such kind of a goal. So I think it's really important.
Yeah, but to be honest, I'm really feared on one side, and on the other side very excited, because I think this, what you identified in your research, is really in line with the identification of the alignment faking and the deception analysis of Apollo research and Anthropic with the alignment faking. And it shows that there must be much, much more effort into better understanding these kind of complex reasoning models, and also better understanding, and also put more effort into safety research if we want to use these kind of models in a high environment, or in a multiplied in environments in which we are living and are interacting. And I think on one hand, it's very good that we have these open source models right now that we can test and try those kinds. On the other hand, these models are so capable and also cheap, then I'm pretty sure that we find use cases where the model are used in the next weeks and months. and we don't have the security barriers right now,
Yeah.
It's,
concerning,
I think,
I would say.
Yeah, it's interesting time, but also a time where we really be carefully from a research perspective. And so I think transparency is a very important part, and also making awareness about these kind of aspects. And I hope that you as a listener could follow us with the ideas. And we would like that if you have some discussion points or anything like that, that you come back to us. Would be very happy. And we hope that we had make you or give you some insights into our research right now. Sudha-san, thanks for your time, that you really take your time and talked a little bit about your work. Have fun for the rest of the week. Thank you so far.
Das war eine weitere Folge des Knowledge Science Podcasts. Vergessen Sie nicht, nächste Woche wieder dabei zu sein. Vielen Dank fürs Zuhören.